So the assumptions here, again, is the simple random sampling that we're going to perform on the population to collect our data. So here I have written n p naught and n 1 minus p naught. This is just another way of saying x and n minus x are both greater than 5. 5 or greater. So whether you want to take a look at x and n minus x or n times p sub 0, that is n under the null hypothesis. It's the proportion under the null hypothesis. So we do have to check to make sure that little check of both greater than 5. And same 5 steps. State the null and alternative hypothesis. We are going to compute the z-test statistic. And the z-test statistic still kind of follows that test statistic or some information from the data minus p under the null hypothesis divided by the standard deviation of our little doohickey here under the null hypothesis. All right, and for computational purposes, it's probably easier to use this form just like we did with x bar and our t-test statistic and our z-test statistic when working with x bar. So for computational purposes, you can do it this way. And again, if we're going to use the critical value method, step number 3 remains the same. Draw the standard normal distribution, shade the upper tail, the lower tail, or both tails, and supply the z critical values that separates and forms the rejection and non-rejection region. And then in step number 4, determine which region that the test statistic falls, and then make a decision. And then step number 5, if you're asked to do so, formalize your results. So this is our game plan, and it's just now we have a new test statistic. So we can come back here to this guy. So let's check this out. So step number 1 is we need to state the null and the alternative hypothesis. Now again, this is going to be with proportions. So the null hypothesis is going to be, well, let's see. The American AAA claims that 54% of fatal car-truck accidents are caused by driver error. Using the 5% significant level, can AAA claim be refuted? So is this going to be our alternative hypothesis or our null hypothesis? The alternative. So what is the alternative going to be? What doesn't equal 0? Here's a hint. So P does not equal 54%, but I'm going to write this as 0.54. So that means the null has to be what? What is it? Thank you. So P equals 0.54. So step 2 is to compute the z-test statistic. So our z-test statistic then is going to equal to, well, we need to come up with p hat. Well, p hat says that a researcher studies 30 randomly selected accidents and finds that 14 were caused by driver error. So p hat is going to equal to what? 14 over 30. And let's just put that in. Okay? You guys, be careful. Don't be afraid of fractions, okay? I think. So we're going to go 14 divided by 30 minus p under the null hypothesis. So what's that going to be? Survey says 0.54 divided by the square root of n. N in this case is going to be what? 30 divided by the square root. And this is going to be p under the null hypothesis. So 0.54 times 1 minus 0.54. So I think probably when it comes to computing this, it's probably going to be easy to, but I think that there's various degrees of how each and every one of you work with the calculator. So for those of you that are still kind of feeling a little fresh, hopefully you kind of feel like pros now, put the numerator in first, put the denominator in second. So let's do that. Let's do it that way. So I'm going to go open bracket 14 divided by 30 minus 0.54 close bracket times the square root of 30 close bracket. And now I've got the numerator in, so I'm going to press enter. And now I'm just going to go divided by, and now I'm going to go to square root. So it's going to be 0.54, open bracket, 1 minus 0.54, close for that, and close one more for the square root. Make sure we got our bracket matching in there. Press enter. So this comes back and tells us that our test statistic is negative 0.8059. I'm just going to take it out to, I'll take it out to 4 decimal places. So Z sub TS is negative 0.8059. So my question to you is just what does your intuition lead you with such a number like this? To reject or fail to reject? Where's your intuition leading you? Why? Why?
Because it's less than one. Less than or negative or more than negative one. Does that make sense? I just feel like no. I'll stop.
No, I wanted you just to say 0.
0.
It was close to 0. Yeah. So this number is kind of close to 0, and we've never had it to where we drew our rejection region. Remember, we reject when the test statistic falls on the tails, right? So for large test statistic, we reject, but this is a small test statistic, so intuitively we can kind of figure out just by looking at this test statistic that we're going to fail to reject the null hypothesis. But let's just continue on for S&G purposes. So step 3 we know is to draw a picture. So let's go ahead and draw a standard normal distribution. And we do have a two-tailed test. So we need to come up with the critical values. And we have a 5%, so how much is going to be in each tail? 0.025. So to come up with our critical values, again, we can just go inverse norm negative E99, I'm sorry, we have to put the area in for this one. So 0.025, and this should come back and tell you 1.96. In fact, I think the calculator will tell you negative 1.96. So since we have a two-tailed test then, same game, so we have 1.96 and negative 1.96. So our t-test statistic negative 0.89. Remember, this is centered at 0. So our t-test statistic is right here. So hopefully, when I asked the question earlier, with our test statistic being so close to 0, we can see that we're going to fail to reject. So step 4, it will fail to reject. So since we're failing to reject, then we're saying that the data is telling us that the true proportion is right around 0.54. There's not a statistical significant difference. So the AAA claim that 54% were caused by driver error. Is the claim refuted? Survey says? Survey says?
Yes.
No, it has not been refuted.